Good morning. This is May, was it 22nd, 2025? Network cabling, ELEC 1013, Fanshawe College, London, Ontario. All right. Today is going to be an easy lesson. Uh, mm, the reason why I'm giving you this lesson is that you will be working. Well, you will be or will be not. That depends on how and where you're going to get the job. But with this course, I'm assuming that you're going to get the job in this field. So that's how I carry this course. Now, how your life is going to turn out, one way or the other, that's going to be up to you. Okay, so while you are doing the wiring, network infrastructures, and anything that has to do with that, mounting the devices, setting up all kinds of scenarios. It is a extremely good idea. It's crucial, actually, that you know the basic terminology and the basics of the basics. As far as if somebody says that something is Citrix or not, are we running Citrix network? So you don't look like like the deer in the headlights. If somebody's talking about horizontal runs, then you also know what they're talking about, and among other things. So this is one of those lessons here that is going to help you understand how to find yourself within the whole environment. All right, so today we're talking about something that's called a network topology, right? And let's get the wheels going here. Sip of coffee, of course, and let's go. All right, so network topology. Boom. All right. So this would be different ways to picturize or symbolize different topologies. Like, for example, a ring, mesh, star, bus, inline or chain, and others like fully connected and a tree and things like that. Today we're going to concentrate on one, two, three, four of those. Okay. Let's go here. Start with the definitions. What is actually a topology? What do we mean by topology? This is the arrangement of a network, including its nodes and connecting lines. We distinguish two ways of identifying network geometry within the topology. What do I mean by that? Well, there is a physical topology and the logical or signal topology. For the most part, for the most part, we're going to concentrate on the physical topology. However, I just want you to know that this also exists. Okay. What I'm talking about is the logical or signal topology. Okay. Boom. All right. So, basic elements of network presentation. Okay. So, what do we have on the left side here? We have hosts or nodes, and we have connecting links. Now, hosts or nodes, there will be computers, wireless access points, routers, switches, hubs, bridges, gateways, and others. Printers and other devices, such as, let's not forget, like for example, IP cameras, or, which I didn't write here, let's say VoIP telephone systems, or any kind of a smart device that is connected to the network and is communicating in one way or another within the network that it's connected to. Now, let's take a look at the connecting links. Of course, from the previous lessons, we would know that we have copper, which would be, well, metallic type of links, which is wiring. We just call that copper. Fiber, which stands for fiber optics, and air, which is associated with wireless communications using radio waves, such as Bluetooth. It is using wireless, it is using radio waves. Wi-Fi, which is wireless access points. It's using wireless communication radio waves. All right, now let's take a look at the first ring topology. Here is the symbol for a ring topology. And in the ring topology, each node, let me just get my pointer here, each node or host, which would be the computer or any kind of a PC or wireless access point or anything that is connected, we consider this thing as a node or a host. So each node or host connects to two adjacent nodes in a continuous pathway for signals, through each node. So this, let's say this is a PC and these are all PCs. They are connected like that in the ring type of topology. And each node, data travels from node to node, with each node along the way handling every data packet as a repeater. Right? Every node acts as a repeater. So let's say this PC wants to send some sort of a signal that is addressed to this node or PC. Well, it is going to try to send the message, and it's going to get the message is going to get to this PC, and this one is going to say, "Oh, this is not for me." I'm going to repeat that and pass it along, and to that, and then until it gets to that one there, and says, "Oh, that's for me," and this is addressed to me, so I'm going to respond accordingly. So sometimes it's a command to do something, display something, or calculate something, or sometimes it's to check something and repeat, reply, maybe, or communicate with another thing. So whatever the command is. So that's how the data travels in the ring topology. Now there's a ring and there's something that's called a token ring. So we'll get to that in very soon. Right? So ring topology hardware. Here's a single port NIC. Okay, and here's a double port NIC. What's a NIC? NIC is, it stands for Network Interface Card. Now, these are the big ones for the full-size PCs. However, every laptop, even a cell phone, it does have some sort of a network interface device, or in short, card. So part of the circuitry will serve as a NIC. Okay? And usually with cell phones and tablets or laptops, it would be wireless, and it also would be wired devices. What is the wired devices? Well, sometimes you're going to see the Ethernet port on your laptop. And some of the modern, some of the models of the laptops or tablets, they don't even have that. They would just have USB ports or mini USB ports, to which you're going to plug in a device that is going to serve as an interface, and physically it will have, let's say, Ethernet port. Excuse me. All right. So in this case here, if we go back, for the most part, would we use the single port or double port network interface card if we want to connect things in the ring topology? Okay, so here's a single NIC port, and there's a double port NIC. Of course, in this case, I'm going to answer my own question here, that we would have to, if we are considering hardware connections or hardware type of communication, then we would have to use, for each node, we would have to use a double port NIC. That would be the basic way of connecting. Now, using different type of geometry, signal geometry, and things associated with that, you could use a single port NIC and still have ring type of a topology, but that's kind of complicating things. Let's just stick to the basic form of what we're talking about, and we're going to build up on it as we go along. So for the ring topology, we would have to have hardwired that type of a network with double port, because every node will have to have an input and an output, or connecting it one way and connecting it the other way in order to form the ring. Okay. Which NIC could be used in? Okay, we just talked about that. We were going to expand on that at the end of this presentation. All right, so here's the ring type of a configuration. The data travels one way, and it keeps going with every node acting as a repeater, so making sure that the message gets to the proper node or host that it's addressed to. Okay. Now, we're talking about the ring, and we're talking about the token ring, as I have promised. Okay. Now, in the ring type of topology, the data travels one way. In a token ring, the data can travel either way, both ways. Applications, well, wide area network, not wireless, wide area network. That's when we're going to talk about later on. We're going to talk about the types of networks, but now we're talking about networks topology. Or metropolitan area network, for example. All right, so here's an example of, well, I would say, well, maybe a metropolitan area network. So there will be just like a local area network, but owned by a city. So all the traffic lights and city cameras and other devices would be connected to something that's called a metropolitan area network, which would be like a really, really built out, built up, a bigger version of a local area network. So local area network would be confined to a building or an office. And the metropolitan area network is just like that, but it spans over the whole city. So let's say here we have different types of buildings here, different buildings, and they are communicating with each other in the ring type of a topology. There's no one main server per se. Maybe there is no need for one main server. Excuse me. And just there's some sort of a communications needed between those whatever offices or data exchange that has to go on. So those can be connected in a ring topology, or they can be connected in the token ring topology, because, for example, if there's a wireless communication between these 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 buildings, like for example here, and let's say the data has to go from this one to that one, from this building to that building. And let's say that this link is broken for some reason. Maybe the antenna is damaged or something. Let's say this link is broken. So if there was just a ring communication, then the message would not be able to get from here to here. But if it's a token ring that the system is going to try to send the data this way, it's going to stop here. So it's going to notice, the system is going to take a note of that. Oh, wow, I couldn't send it that way. What happens if I send it maybe that way here? All right. So maybe, then, okay, within the token ring, that would be possible. Right? Excuse me. Okay. And over here, we can, as we go along here, we can just stop for a second. I can say, okay, this is a wireless communication. And some of it is done through the fiber optics wires that are run underground. Just a notice kind of a thing, different type of links. So with this slide, what you need to remember is that there's a difference between the ring topology. Topology is basically type of a connection or arrangement, how the network is arranged as far as connections. So there's a ring topology. Within the ring topology, data only travels one way. And with the token ring, data can travel one way or the other. So that opens up possibilities that if one of the links is damaged, the data can still get to where it should go, but it can use a different route or different route. Okay. Now, applications for a ring topology, it would be, for example, in the LAN configuration, and LAN stands for local area network. And the local area network, we'll talk about that in next time we see each other. It's not going to be this week because this week was short week. So the network types class is going to be presented to you this year, next week. Right? All right. So example of a ring topology connection. Let's say in the main communications frame or distribution frame or communications closet, local area network room, there would be equipment rack. And as we know by now, or not, maybe not yet, the way things are arranged, there would be main equipment rack. And the main equipment rack is going to have a patch panel with a bunch of different Ethernet ports. And there's going to be destination locations or field locations. Let's say there's an office that consists of, well, maybe 1, 2, 3, 4, 5 computers. So those all those PCs are going to be run with a cable. These jacks are going to be, they will run home run, what we call it. So each jack is going to have its own other end, like a separate jack. So it's a dry connection, just what we're doing during this lab. We're connecting a straight link between two data jacks. So that's the connection between the field or desktop location or the destination location and the patch panel, just a dry link. Here's a jack and here's a jack. That's it. To that jack, there's going to be a PC connected through a patch cord. And then there's going to be something that's called a switch or a hub. And there's going to be a video I'm going to ask you to watch to so you can actually distinguish the difference. So you can know the difference between the switch and a hub. Okay. You need to know those kind of things. So then one-to-one basis, because switch is in the layman terms, a switch would be, in the simplest way to describe it, would be like a traffic controller for the data signals. So on one-to-one basis, there will be a patch cord that is connected from one port to another on one-to-one basis. And then the switch can be connected to other equipment, such as a router or media converter or whatnot, whatever the switch needs to be connected to. But let's say that there's so many PCs that the one switch cannot handle the number of the PCs, because every single PC has a port in the patch panel, and it's connected to a single designated port in the switch. So let's say there's so many PCs here that the switch is, we run out of ports. So we can add another switch. Right. If we run out of space, we can add another switch, and so on. And those switches are going to be connected to each other so they can act when they're connected to each other, so they can act as one giant switch. And that one giant switch can be connected to wherever else needs to be connected. So in this case, we would connect those switches, like, for example, in a ring configuration. So there are separate ports in the switches that can serve as the connecting links between one switch and another. So we would connect those in a ring configuration so they can act. Those 4 switches can act as one big switch. Now, here on the bottom, I included the link to a YouTube video that explains the difference between hub and switch and a router. So watch that video, please. This one here. Actually, here, the next slide. Watch those two videos. It's 7 minutes here. 7 minutes out of your life is going to, if you don't know what the difference is between hub, switch, and a router, then that's going to give you a good indication on that. Then there's an example of setting up or on chain or ring topologies between switches. Now, this is a 5 minute and 45 minutes, well, almost 6 minutes, 5 minutes, 45 seconds, excuse me, video. But for this purpose, just watch the first minute and 42 seconds. Later on, that person explains how to set things up, and we're not interested in that. I just want you to see how things are being physically connected. All right, let's move on to something that's called a star topology. In a star topology, we have one main node into which all other nodes, so-called home run, a home run connected star topology. Each node or host of a network is attached to the central node, right? Central node. The central node is usually a hub or a switch, but the central node can also be another proprietary device or specifically designated device, such as NVR, for example, as a network video recorder, and that's used in the video surveillance system, which was basically a security cameras system, right? Now, star topology, so it's not always a server. It could be another device. Star topology is the most common physical wiring configuration, considering horizontal network wiring. Well, okay, see, so here's the thing. With every slide, you learn something new, but there's always at least one more question. What is this? What is that? Yes, we're going to get to that. So I just want you to know that the star topology for networks these days, right now, and right now we have the year of 2025. And for a while, it has been like that. And for a while, it will be like that. Right? That the star topology is the king when it comes to basic network or local area network configuration or topology, which means everything is connected to a central switch. And how is it done? Just like that. Okay. Just like that. So when you have a big wiring job, a lot of time you're going to spend, or you're going to spend a lot of time doing this, just running wires, running wires, running wires. So wire installation is a huge part of this network infrastructure type of a job. And then there's termination, and then there's connections, and then there's setting things up, physically putting it on the table, unpacking, and then there's configuration of this, whatever system you're installing. Sometimes you're going to get to configure things. Sometimes you're going to make way for other people to configure their equipment. It's all kind of a network connected. Electricians work with the data people or the data people. Electricians will work with the network installers. The network installers will work with the IT people, and the IT people will work with whatever other people. So it's all connected, type of a thing. Right? And there is enough jobs for everyone. It's just a matter of question, what speaks to you the most? What is it that you want to do the most? So just go that way, pursue that direction, and do it. Right? So here's a concept diagram of star topology. Everything connects to the home runs to the one central node. All right, star topology in the local area network configuration. Well, see, that's how the wires run to the patch panels. This is a big job. This is definitely a big job. So this would be all the network wires run to the patch panels. And from the patch panels, on the other side, they're patched. to the whatever devices, like for example, a switch or a gateway. Well, not maybe a gateway, switch or a hub, usually. All right, so that's how things are done. Okay, when it comes to star topology and networks being installed this way. Now, what is a, well, star topology? Can you identify the star configuration? Well, here's one. Okay. Here's one. And that's pretty much it. So this will be the star topology here. All these run to the central location here. And when you're having all these three running to this home running to the central closet that is central to these three, that's considered a horizontal run. Yes, the wire will go up vertically to the ceiling, across the ceiling, and it's going to go down vertically, inside the wall in a pipe or conduit or any type of raceway, excuse me. And yes, some of the, but we consider that as a horizontal run. In fact, if that one there would run across the floor and be connected to this closet, so this PC would be considered as part of this horizontal run. Now, also we have something that's called a riser, which is the vertical run. And most of the modern buildings right now are arranged in a way, especially those business buildings, Toronto downtown, London downtown, any kind of downtown financial district, business high rises and old hospitals and other things. Most of the time they will be arranged that the communications closet will be kind of arranged vertically, so there's easy access from one to the other. So from the main cross connect or the demarcation point, and demarcation point is point of entry, or main distribution frame, things are being called different ways. Then the communication can be run from one floor to another. And if you have 40 or 50 or 60 floors, it makes things not easy as much as it does make things possible at all when it comes to data networking. All right, so this would be called a riser, and this would be called horizontal runs. These would be called horizontal runs. You see intermediate cross connect, or MDF would be main distribution frame. IDF would be intermediate distribution frame. So see, there is a different terminology. Sometimes there's intermediate cross connect. Right? Cool. Or intermediate distribution frame. Same thing. Sometimes people use, or yeah, sometimes terminologies are being exchanged or used in a different ways. So also here is something that's called a backbone. Here's will be the backbone of the whole system. Actually, the backbone would be like this here to the many networks, many local area networks, because this could be a local area network for this type of business. Then there could be, this could be a local area network for another type of business that is completely independent of that. But this will be the backbone of the whole building. Do you have a backbone at home? Yes. You have internet connection and you have some sort of a modem, which also serves in the same box. It's acting as a modem, as a router, as a switch, and as a gateway. So that box itself is a mini backbone, but it is a backbone. In some sort of a business or an office, this would be the backbone. Structured network cabling. Let's go. Okay. All right. Most popular physical cabling topology is the star topology, as we said. And here's another visual. on how things are wired. So here's a wall plate or destination type of termination, and there's a home run wire, home run connection. It's a home run connection that goes to the patch panel, each on the individual basis. Each jack here has a corresponding jack there. It's a dry connection from one to the other. For what's going on with me today? For every single one. And then, of course, you patch to the switch, and the switch is connected to whatever the arrangement of that the whole thing is. Boom. Now, here's a bus topology. We have already used a bus topology. Remember when we did the PA system? We had a bunch of speakers. And here was the amplifier, and here would be the main connection, main bus line. And there will be a speaker station, there will be a speaker station, there will be a speaker station, and so on. So here and here and here and here and here and here. Those stations are connected to that main bus line. They're tapped in to the one main line. And that's it. This is the bus type of a configuration. So same thing with some networks. It used to be until mid-90s, towards end of 90s, the computer networks would look like this. They would not look like the star topology. It would be one main, and it would be a coaxial cable. I think it was RG58 that was being used. And wherever this PC station would be, that coaxial cable would be interrupted, and a tap would be installed. So the signal will be tapped in, but there will be a one main bus, just like the speakers that we connected. Okay. And the communication would be solved with different types of protocols that would enable you to use that one line as the main communication carrier or physical carrier, to either for those PCs to talk to each other or maybe talk to the main server. How is it that they would be able to use one line to communicate? Same as, for example, just think about it, the air that surrounds us. There could be your cell phone could be connected to the wireless access point in the ceiling using the same airspace as your friend's cell phone connected to the wireless access point. So it's just the airspace is being used as that kind of like a cloud bus type of a thing, except it's not wired, it's the airspace, right? So it can also be solved with a couple. Those types of networks are not being used like that anymore because we have the star topology and things are being solved a little bit different. Why am I showing you this? Well, I see that you can tell when I wrote this presentation here. So bus topology was used in LAN settings up to early or mid 1990s. Presently, well, now it's 2025. All LAN are wired in the star configuration. That doesn't mean that the bus topology has been wiped out from planet Earth. Bus topology, although the bus topology is not used in the LAN settings anymore, it's still implemented in certain systems. Like, for example, the most primitive way I can explain to you, it would be a fire alarm device's connection. a zone in the fire alarm, which zone is a connection point, and it could be designated as east wing smoke detectors or west wing pull stations or something like that. So there's just one line that keeps going to the end and has two wires, two conductors. It's a pair, and it's terminated with something that's called the end of line resistor, because the zone has to know that the whole line is intact, because those devices for the fire alarm are normally open. So when they're normally open, they're not even being seen by this terminal here. But this terminal here needs to know that this whole line is intact. So that's why we have the end of line resistor, and it has to be at the end of the line. So when any device is being triggered, it's going to short. It's going to create a short, and that zone is going to notify the main panel that there is trouble somewhere in the east wing, smoke detected or something like that. So that would be the bus topology. Another thing with the security alarms, for example, here is the close-up of the main board of a security alarm. These four screw terminals, for example, here's auxiliary power, and that would power up smart devices or active devices. And here is the bus. It actually says bus. It says green and yellow. So, for example, we have keypads. Let's say that the power has to be connected. So, yes, it is connected. So each of those keypads was going to get 4 wires, red, black, and green and yellow. But I just didn't draw it to not pollute graphically this presentation here, this slide. So aside from being a power connected, there is a signal connected in a bus configuration. You see, this keypad here connects to the main bus, and it's connected to the main board. And so is this connected to the same bus, but because of the communication protocols being used, just like the radio waves for the walkie-talkies or cell phones or tablets and laptops, these keypads will have different types of addresses, different types of designations within the communication protocol, in a way that at the same time, both keypads individually can communicate with the main board in a bus type of a configuration. Now, here's an inline or chain topology. In this configuration, nodes are connected to each other through each other in a chain configuration. Here's the symbol of that. These 4 switches are connected in a chain topology. These 4 switches are connected in the ring topology. See that? Here, and then it goes here and here. So it's like in a circle. These are connected in a circle type of a topology, which would be ring topology. And these would be or inline or chain topology. Quite often, this topology is used within the control devices in the industrial setting, like different machines that are part of the production process. They would have modules installed on them, control modules, and those control modules serving each machine. Those would be just connected in the inline or chain topology. And quite often through those, there's very little communication or minimal communication going through, maybe just setting up some type of a process, and then and the communication is done. Maybe some program has to be uploaded and the communication is done. So those devices would be connected usually in a chain topology, just one to the other, one to the other. Okay? And maybe there's no need for a ring topology to be used, because that's all it's needed in certain type of a setup. So let's say here, in this configuration, nodes are connected to each other through each other in the chain configuration. Each node acts as a repeater. As opposed to the ring configuration, the last device is not connected to the first device to form a loop pathway. Okay? So there's a difference between chain and a ring topology. Oh, there's some geese flying by. Inline or chain topology. Now, Let's get you some real life examples. And by that, also, you're going to be familiarized with certain devices that you didn't know existed. And after this presentation, you will know that some of the devices exist. Of course, you know what, excuse me, what a printer and a laptop is. So I'll just say workstation and the printer, in this case, they're connected to the switch in a star topology. Can you see that? Yeah. Now, in this case here, this printer is connected inline with the server, or there's an inline configuration. In some cases, the printer doesn't even see the switch, but this would be a physical inline topology as opposed to star topology. This would be used in larger corporations when there's a floor of different offices, and maybe you want to have one huge printer or two printers common to everybody. And if somebody wants to have printer in their office, they could have that configuration as well. Now, let's see here. This Ethernet extender is connected in inline with the Ethernet link, within the Ethernet link. Okay, why would you use something that's called an Ethernet extender? Okay, for the most part, I just have to say that now because some changes have been, well, there's some discoveries that have been made or inventions. But let's say the Ethernet link with Cat5e or Cat6 or Cat7 is the longest distance it can run end to end is 300 feet. It's actually 328 feet. However, you're not going to install 328 feet end-to-end link because you still have to use patch cords. Right? So 300 feet is the agreeable distance. And if there's more than 328 feet end-to-end, then the data will be intermittent. It's not going to be and I don't want to use the reliable or unreliable because there's also a technical term of reliable and unreliable transmission. But aside from that, the connection is not going to be reliable as far as functionality, not as type of communication, as functionality. So sometimes the data will go through, sometimes some of the packets will be missing, and things like that. So in that case, you can install something that's called an Ethernet extender. So you can have 300 feet between here and here, and you can have another 300 feet between here and here. And usually you don't. Usually you just have somewhere 200 feet here, or maybe 280 feet here, and maybe 60 more feet over here. So that's going to give you more than 300 feet. Now, the data transmission is going to be slower. However, in some cases, the speed is not that crucial. Like, for example, a cash register. The data speed is not that crucial with the cash register because sometimes you're just going to send a transaction, boom, and it doesn't matter if it goes light speed or is it going to go a little bit slower. That transaction is going to go through and it's going to be registered by the system and so on. So quite often that is being used in retail environment like that. When you have to have high-speed Ethernet connection, then maybe this is not the best solution. But in some cases, it is. So I just want you to know that a device like that exists. It's called Ethernet extender. Where does it get? It has to be powered. It's not a passive device. It's an active device. There are two ways of powering it. There will be the power input here, power jack, which you can just connect with the regular kind of like a so-called transformer or power supply locally plugged in. But if you don't have that, you can also use the PoE, power over Ethernet, but the switch has to be capable of power over Ethernet, which means that aside from a signal being transmitted through the cable, there's also power transmitted through the cable or being carried through the cable. So this way you don't have to plug it in. The power is getting from there. All right, so Ethernet extender, it's a device that exists. Now over here, another thing that can be put in line is something that's called a PoE injector. power over Ethernet injector. See, you can have a switch that is capable of those ports will have PoE, power over Ethernet, installed or wired in or part of the whole thing. And some of them will just have the signal with no PoE on the ports. Of course, the one with the PoE will be more expensive. So that's why sometimes some companies decide to go the less expensive way and just get the switches without the PoE. But if you have to have PoE and you didn't get the switch with the PoE, what can you do? Well, we can replace the switch, but that is a huge operation because you have to reconfigure that, and it could be a bigger surgery, quote unquote, so to say. So what you could do is you just have one device. Like, for example, you have decided that, yeah, your clients are asking, everybody comes to your shop, is asking, what's your Wi-Fi password? Oh, I don't have a Wi-Fi. Oh, you know. So, okay, well, you can install the Wi-Fi in the ceiling somewhere so your clients are happy that you can give them the Wi-Fi password, but your switch doesn't have the PoE on its ports. You can get a device that you can plug in, and usually you will have place to plug in because this goes where the communication closet is, so there will be all kinds of power available there. And you can just plug it in instead of straight into the wireless access point. You can just plug it into the PoE injector, and from now on, here the signal is all going to have also power injected into it, so the device doesn't have to be plugged in anywhere. It is going to get its power from the Ethernet cable as well. All right, another, we're almost done, guys and girls. Inline chain topology example. Here's a VoIP telephone system. We will study that in greater detail later on. So this VoIP telephone, voice over IP, which is the internet or Ethernet telephone, is connected in line with the workstation computer. Right? Of course, the VoIP telephone producing companies, manufacturers, they want to sell as many products as they can. The more they sell, the more money they make. And they want people or companies to switch to VoIP from the regular POTS, which stands for plain old telephone service. They want them to switch because that's how they make money. And of course, there is a incentive for the client to switch to VoIP because they do save the money a lot. They actually can save a lot of money by switching to VoIP. So also they want those things to be sold, and the more convenient the installation or retrofit or the change on the system, the more convenient it is, the more easy it is for the client to make up their minds to actually go for it. So it's the VoIP needs a data jack. So what do you do in order to have that? You're going to have hire a company who is going to install additional data jack in every single location. Well, maybe you don't have to because those telephones will have two jacks, one input, one output. So if you have a PC already that is connected to a data jack, you can just put the phone, VoIP phone, in between. So you can unplug that PC from the wall, plug that into the phone, plug the Ethernet connection right to the phone, and from the phone, plug it into a PC, and you're in business. You don't have to go through additional huge costs of running additional jacks in installation. Okay, so that's so the telephone, the VoIP telephone is in line with the PC. A solution that is quite common within the retail business, big retail business like Home Depots, Rona's, Home Hardware, all kinds of others, Walmart and whatnot. You're going to have a POS, which stands for point of sale. And if you look closely, there's going to be a VoIP phone on that desk or POS desk, and that is going to be plugged into the network jack. And from that, there's going to be connection to the PC, which is a cash register, which is a PC. Um, Consider, okay, when we talk, I'm just going to, last thing I'm going to explain to you is the geometry of the physical or the signal routing geometry of the network. All right, so consider PCs, PC 0, 1, and 2, right? PC 0, 1, so these are those three PCs. Are the PCs connected to in a ring configuration? No, they physically connected as a star configuration to the switch, all right? Is it a star? Yes, it's a star. Physically looks like in a star. Technically, hypothetically, it can also work as a ring, depending on depending on here's a star configuration. It can work as a star, it can work as a ring, depending on how internally this switch is configured. It can work as a star and can work as a ring. This is my desperate attempt to explain the geometry between the star and ring configuration, even if it's connected and physically in a star. Of course, this is a highly hypothetical situation. It probably doesn't exist, but this is just to explain what the difference is between the physical and the logical or signal topology. All right. Lab foundation. This is a patch panel which has a bunch of jacks installed. The patch panel is installed in the equipment rack at the main location, the center of the home run of the star topology. On the other side of the patch panel, there are termination blocks that correspond. Each termination connection corresponds to each jack, and they are numbered. See, here's 24, 23, 22, 21, and so on. You can see the numbers here. This is a jack that goes on the other side of the link. We are doing this week. There's a data jack. Here's a cable. Now, here's the difference between Cat5e and Cat6 and up. Cat5e will have twist. Every pair is twisted. And you see the pairs are twisted at different rates of twist. Just so there's just to eliminate the possibility of something that's called a crosstalk. We'll talk about that later. Now, the twist eliminates crosstalk. Now, Cat6, to eliminate more crosstalk, will have tighter twist, more consistent twist within the pair, but also the twists are different, so they are not twisted at the same rate, so the crosstalk still is getting eliminated by that. Plus, all the pairs are arranged inside something that's called a separator right here. Each pair has its own channel in that separator, and the separator, it's like a kind of like a cross type of a configuration that goes along the cable inside, and each pair has an individual channel, and that separator, it's twisted as it goes along. So the pairs are twisted on their own, and they're twisted around each other to have better crosstalk elimination effect here. So the difference between, you can tell right away, if you strip the cable, Cat6 will have that separator, Cat5e will not. Insulation. Okay, IDC. I'm not going to read the history of it. I'm going to encourage you to read the history of it later. IDC connection, insulation displacement connection. This is a bit wrong here, but I decided to leave it anyways, just so I can bring your attention to it. I got this thing somewhere from the internet, and here's the reference. Insulation displacement connection. Here's the connector. The wire is being pushed into that connector. That connector bites into the insulation, makes contact with the copper wiring inside. Thus, it's called insulation displacement connection, IDC. Okay? And this is how things are being done. We're doing the lab. We're doing those connections. This is one example of IDC that we're doing right now. What's wrong with this one here is that here it's shown that the wire inside is stranded. IDC is not made for stranded cable, for stranded conductor. I kept it so I can bring your attention to it. It is made for a solid wire, because if the connector bites into the insulation makes connect, it can actually cut some of the strands. So it's not really meant for stranded wire. It's made for a solid connection. And that's it for today, ladies and gentlemen. Thank you, and have a wonderful week.